So you asked for more punishment, and I'm going to give it to you. And the next video, this video, is going to concern our next set of amino acids. So we've talked about five. We've looked at their structures, their names, their three-letter and one-letter abbreviations. And those five, I would take 1 week and just sit down and act like a crazy person and just write those structures over and over and over and over and over and over and over until you feel comfortable with them. So we've talked about glycine, alanine, valine, leucine, isoleucine, aliphatic side chains, which are basically just hydrocarbons. In this video, we're going to look at two hydroxy-containing amino acids. Okay, so hydroxy-containing. So hopefully you've made it this far in organic chemistry that all of you should be comfortable with the term hydroxy, and hydroxy means OH group. So we're looking at a OH group here. These amino acids need to have OH groups on them, probably, as far as their R group is concerned. So let's take a look at our first one, and our first one is a CH2OH. So that CH2OH group, this is what we would call a hydroxymethyl group. So hydroxy OH, one carbon, the name of one carbon is meth. So hydroxymethyl group. A hydroxymethyl group, CH2OH, well, this amino acid goes by the name of serine, S-E-R-I-N-E. Three-letter abbreviation, doesn't take a rocket scientist, S-E-R. And then the one-letter abbreviation is going to be S. So there you go. It kind of meets the trend that all the other ones have so far. We don't try to make it complicated on you whatsoever, but there is serine, hydroxymethyl amino acid. Okay, so there's one out of the two that are hydroxy containing. So let's look at our second one now. So we're going to put serine up here at the top. That's our first one. And then our second one, well, what we do is we just add another carbon onto the picture. So CHCH3, we just add another carbon, and then on this group we still have the OH. So the carbon that's attached to the alpha carbon still gets the OH group. The only difference is that we add another carbon and elongate the chain a little bit. And this is called a hydroxyethyl. If I really wanted to be particular, it would be called a 1-hydroxyethyl group. So this amino acid that has a 1-hydroxyethyl group, eth is two carbons, two-carbon chain, hydroxy on that two-carbon chain, that 1-hydroxymethyl or ethyl group is going to be called threonine. So T-H-R-E-O-N-I-N-E, threonine. Well, three-letter abbreviation, T-H-R, and one-letter abbreviation, T. So again, we don't try to make it complicated. There you go. There's threonine, THR with a T. So that is our second hydroxy-containing amino acid that we will look at. Okay, so that brings our total to 7, but we're not finished yet. So let's erase this threonine. We've talked about these hydroxy groups, a hydroxymethyl and hydroxyethyl. Notice that these R groups don't get very large for the most part. They kind of stay very small and compact, right? So our next ones, if we can have amino acids that contain O groups, then we should have amino acids that contain S groups as well. So these are sulfur-containing amino acids. And they're very similar to the OH, which is why I like to talk about them together, because serine was a CH2OH, and this amino acid is a CH2SH instead. So instead of the OH on the end, it's an SH. We call this a substituted alanine. So it's a sulfur substituted alanine. Alanine, of course, had a CH3 group there, right? So we take one of the hydrogens off and put the SH group on. This amino acid is called cysteine. So cysteine, cysteine. It goes by a 3-letter abbreviation of CYS and a 1-letter abbreviation of a C. That structure you should know as well. So sulfur-containing groups, our first one is cysteine. Very similar to serine. The only difference, this one has an OH, this one has a SH on the end. So there's our first sulfur-containing group. Okay, so let's get rid of cysteine, CYS, and C. And let's get rid of this group because we're going to change that up a little bit. And in the next one, it's kind of similar to threonine, but it's slightly different. We elongate the chain from cysteine. That is true. We do elongate the chain. This goes to a CH2, a CH2, a sulfur, and then a CH3 group. So we elongate the chain by 1 carbon. We put sulfur in kind of the long carbon chain that would be there, and we put a methyl group there on the end. This is what we call 2-methylthioethyl. So that's something that you don't need to memorize. All of these are just general knowledge. This is what we would call that type of substituent. A 2 parentheses methylthiol ethyl or ethyl. Okay, so what do we name this amino acid? Well, this goes by the name of methionine. 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 3-letter abbreviation, MET, and 1-letter abbreviation is a M. So there you go. There's your second sulfur-containing group of methionine. Okay, so there's 4 more that we can add on to our what was 5. So this brings our total to 9. We are almost finished. So we've talked about the aliphatic side chains. We now look at hydroxy side chains, and we now have sulfur-containing side chains. So here's 9 amino acids. Our list will continue to grow, and in the next video we'll take a look at our amino acids that are acting as a base and an acid. So stay tuned, there's more. There's 11 more of them, and yeah, you gotta know all the structures. Wonderful, huh?